if you wanted this to go only one way, would you use the reversible way? Would you use sodium hydroxide if you wanted all of it to be on one side and you didn't want the reaction to go in the reverse direction? No, right? No. So normally, I would not bother you with all of it, okay? But we have to do it reversible and irreversible. Reversible would be with what? With sodium hydroxide. Yes? Hello?
Yes.
With sodium hydroxide, because the pKa of course, sodium hydroxide, they're pellets of sodium hydroxide, right? It's a solid. I don't want you guys to get confused, yes? Sodium hydroxide, does it have to have a solvent in there? It has to have a solvent that dissolves these things, yes? Yes or no?
Yes.
Is the solvent water?
Yes.
Yeah.
Water or
Could be water. This is why it's reversible. But once you form this, since the pKa is similar to that of, let's say, water and alcohol, then what happens? This takes a hydrogen, or it takes a proton from water,
okay.
and it goes the other way.
Oh.
Yes or no?
Yeah.
That's why it's reversible, because they have similar pKa's. If they do not have similar pKa's, then the reaction is considered irreversible, yes? Because the equilibrium will lie to one side a lot more than the other.
Exactly.
So, sodium hydroxide is reversible. What else is reversible? Alkoxides are reversible. For this type of alpha protons, yes? If I use a source of hydride, like potassium hydride,
Irreversible?
like calcium hydride, or sodium hydride, what this is going to do is going to be irreversible. Now, question is, why is this irreversible? It is irreversible because when that H pulls one of these H's, you form
gas,
H2,
that's right.
which is a gas. That's a big deal.
Yeah.
Okay? That's a big deal. Now, I have annoyed Sophia all semester long by not giving her, or Karen, by not giving them the products of everything, yes? All the products. But this one, in this case, is important. Okay? HCl was important too. Yes?
Mm-hmm.
All the rest of them are not important, so I didn't teach them to you. So, what do you get from here is the same thing as that, irreversible stock. And if we use LDA, which is, what's LDA? Lithium like dialdehyde, yes?
Lithium diisopropyl amide.
Lithium diisopropyl amide, yes? Did I write the structure? I wrote the structure, didn't I?
Yeah.
What type of base is it? Type of base is it?
It's a nitrogen base.
It's a nitrogen containing base, but deprotonated, right? So it's not an amine, right? You make it from an amine, but it was not an amine. You pull a proton off from this thing, so it looks like this. This looks like what type of base that you have seen before?
Amide.
We used it for triple bonds before, right? You seen that base before?
Mm-hmm.
In the book. In the book? It's in the book. It's online too. Okay, so that's what that is. Because LDA, the difference in pKa between LDA and that is so big, the reaction, most of it lies to the right. yes? Now, on the test, if I want irreversible formation, most of the time, you want to choose this or this, right? You choose sodium hydroxide, it's fine, but you're suspicious. But I'm going to tell you when you choose which one. So, this is called alpha bromination, yes? We did this last time. Alpha bromination. And during alpha bromination, what we have is we have something like this. And tell me, what do we have to treat this with? This is, what chapter is this? Enolates, yes? So we're going to treat this with a base. The base could be sodium hydroxide. It's not the best base? Probably not, but it's the cheapest base. Sodium hydroxide, and then Br2, which is BrBr, yes?
Yeah.
So you will pull alpha proton, and this will attack the bromine, that will leave, and you will have bromination in the alpha position. Yes or no?
Mm-hmm.
Hello?
Yes.
That's alpha bromination.
The
Now
carbon
the problem
attack-
is,
The
what?
bromine or the bromine attack the carbon?
No, no,
Yeah, the
the
carbon.
carbon is the girl.
Yeah.
I mean, the carbon is the boy, yes? The carbon,
So they're gonna attack the boy.
no, the carbon is the boy, you see it? That's the one that's gonna do always the attack, right? I mean, I did this before, but probably you guys missed it. I said, this is the boy, and I wrote it. There is the... I don't know what to say, but, okay. I always said the boy attacks the girl, yes?
Yeah.
The boy's got it. She don't got it, but she wants it though.
She receives.
So, that's gonna do like that, okay? And it will be Br minus, yes?
Yeah.
Where is this Br minus going to go?
Floating around.
Is Br minus, and what happens here to the, there is going to be H2O in there, yes?
Mm-hmm.
And it's going to be Br minus, but if you look here, you lose this proton, and that will be HBr, let's say. Okay? But of course, HBr is a strong acid, yes?
Mm-hmm.
So it will be neutralized with the sodium hydroxide, depending on what you did. So now, once you put this Br here, now this bromine, can it undergo another alpha bromination? It can go another alpha bromination. So now we have a problem, yes? Do we have a serious problem?
Mm-hmm.
We have a serious problem in which methyl ketones, here's a ketone, and that group is a methyl group.
Mm-hmm.
Methyl ketones undergo alpha bromination, and after you do this, that hydrogen is more acidic than before. This hydrogen is more acidic than it was here. Okay? Because of the effect of this bromine. And then it's going to undergo another alpha bromination. But I'm not going to do that one yet, okay? I'm just going to leave it like that so you don't get confused. Okay? That other reaction is called haloform, which you probably did in the lab. Did you do a haloform test? Iodoform, yeah.
Oh, okay, yeah.
I mean,
Yeah, I mean, yeah, that makes sense.
yeah, haloform is chloroform,
Okay.
iodoform, and
Bromoform.
bromoform.
Okay, that makes sense.
They treat the water you drink in your house with chlorine. Did you know? And guess what is the reaction that is happening inside this? That's the reaction, haloform reaction. Okay? So the byproduct is chloroform.
So what you mean tap water?
Yeah.
Me neither. I don't drink that shit.
You were gonna say that.
We can form, let's say we have this. Okay? Now, in this case here, where there is a minus here, what is doing the attack is what? The carbon, yes?
Carbon, yeah.
So, the one that is attacking the electrophile, in that case, is the carbon.
Right.
But is that a good resonance structure?
No.
This is not a very good resonance structure. Is that a resonance structure?
Yeah, because the O can hold that minus charge
Okay?
better.
And now there is a minus charge here,
Yeah.
which can also attack the electrophile.
Mm-hmm.
Okay. Now what happens most of the time is the carbon is the one that attacks the electrophile. This is carbon attack and this is the oxygen attack. The one that we care about in this class is this one, yes?
The carbon attack.
Yes?
Mhm.
But somebody might tell you, oh, is it possible that this attacks it too? And the answer is yes, it's possible. Is that what happened most of the time? No, that's not what happens. Because a carbon, let's say a carbon something else bond is more stable than maybe an oxygen something else bond. Okay?
Yeah.
It'd be a stronger bond. So, what's this called from here to here? Yeah, it's resonance. But how do you, the whole process from this to this is called what? Tautomerization, yes?
Oh, yeah.
Tautomerization. And tautomerization can be started with an acid or it can be started with a base.
Base, yeah.
How acidic is this? These two protons here.
Very,
These two
very
protons here
acidic.
have a pKa of around 9. That's very acidic, yes?
Mhm.
pKa of around 9. Is this more acidic than acetaldehyde? Or is this more acidic than, what is it called? Ethanol. Is that more acidic or less acidic? Ethanol or acetaldehyde is 15 point something, yes?
Yeah.
This is 9.
more-
This is more acidic.
yeah.
Why is this
Because you
more
got the
acidic?
two carbonyl
this.
groups.
Why is this more acidic than that?
Because you got two groups.
Positive.
Because by resonance, I can put that negative charge here, or I can put it here.
Okay.
It is more resonance stabilized than this one. This one has only one oxygen,
Mm,
while this one has 2.
okay.
So if I were to treat this with sodium hydroxide, or with an ethoxide, okay, this would be considered almost irreversible. The reaction will lie to the product more, okay? So we preferred bases for this type of group. I mean, we can use LDA too. We can use all of them in hydro. But we can have ethoxides as a better base for this, okay? Let's do some of this. Still alpha bromination. What's the product?
You got that with a CH3,
That's the
a
whole point.
CH2, and a BR.
Because I was told to go see more headlines. Wow.
No, it's not because it's monomer.
Well, like, since I don't have a metro, why would it go there and not in the
I'm gonna show you. Okay, guys, what do we do first? We look at the alpha protons, yes?
Uh-huh.
Alpha protons. Does this have alpha protons here?
Yes.
Yes.
Yes or no?
Yes.
Yes.
Yes, it does.
Yes, it is.
It does.
How many hydrogens does
Two.
this thing have?
Two.
Two hydrogens. Those are alpha, yes?
Yeah.
Alpha is the carbon next to this, the two alpha protons. And does this have alpha protons?
Yeah.
Yes.
How many?
One.
One alpha proton. Does this thing here knows which one is more alpha than the other?
No.
It pulls one from here, yes? And it pulls another one from here just the same. Now, is the product that you are going to get as the major product, what is it going to be? This is what happens. When you pull it from this side, this is what you form. And when you pull it from the other side, that's what you form. Yes or no?
Okay, yeah.
Because it's a double bond, okay? We have been placing electron pairs there. Electron pair here, electron pair
Yeah,
here.
yeah, yeah.
By resonance, this is a double bond on this side or double bond on the other side. Which one is more stable?
Right side.
The right.
The one on the right side.
Yeah.
This is more stable. And why is this more stable?
Right
Is
side.
it? Yeah.
Because this
Tri-substituted.
is tri-substituted? Yeah, you can think of it that way. 1, 2, and 3
Three,
carbon substitution, but it has an oxygen there too. Okay? But no matter
Resonance?
what, this has more substitutions than
Than
this
that,
one, yes?
Yeah.
So, because this is more stable, the major product of this is going to be where the more stable one was. So the major product will be there. But you are also going to get the other one, yes? And most of the time, we don't worry about this too much. So this is the major product, and this is the minor product. Sophia, do you understand?
No, I just walked it back in.
You just walked it back in.
I don't get that. How would you know which one is more stable?
Was that organic one?
Yeah,
Mhm.
side says.
Yeah, side sub rule. Yeah, man. If you have this with R groups all over the place, this is called tetra-substituted, which is more stable than tri-substituted. And that is more stable than di-substituted. And this is cis-di-substituted. And you can have trans-di-substituted. Trans is more stable than cis, yes? So, if you are going to have a double bond here, you might form double bonds that are either cis or trans. And the trans is most of the time more stable. How is that?
Professor, for the first example that you did, the bromine added to where the alpha hydrogen was on the carbon. Here in this case, it wouldn't add at the end of the methyl group because the alpha carbon is the one that's right next to the ketone.
Yeah, that's
Okay.
not alpha, that's beta.
Which the last one is beta.
No, no, what do you mean the last one? There is no last one here. Why? This is the last one? Girls always do this. Why do you say this is the last one? This is the last one? Why is it last?
What do you mean? This is
It's
at
an
the end.
appendage, yes?
Okay.
It's an appendage. is a body part. It's not last or it's first, it's just part of it.
Right.
Alpha are the ones that are next to it, yes?
Right.
And this you can say is beta because it's next to alpha. And this one here is
Beta.
beta, and this one here is beta.
Yeah.
Because the betas are next to the alphas. And this is gamma because it's next to
The beta.
the beta on that side, because next to the beta on the other side is alpha. And you start from here, yes? From the carbonyl. The hydrogen that gets pulled off is the alpha hydrogen. There's two here, one there. This one is the one that gets pulled off more often because you form
The double
the
bond.
more substituted alkene.
Yeah.
It's not alkene,
right.
it's not an alkene, it's a more substituted enolate.
Bless you.
Just kidding, guys, okay? It came from the heart, yes?
I think you need a Snickers.
I don't know, I haven't slept very well the last few days. Life doesn't stop. I've been waiting, since 17, I've been waiting to catch a break. It hasn't happened. It's just getting worse.
The first one.
Alicia, what you talking about, man?
Going to the bathroom.
This condition, you can do beta if you do an elimination. You'll have some type of formula. You can add HB on
Maybe they get like double bond on the carbon and then have the
Okay, guys. So what do we get here?
The CH2Br?
CH2Br.
CH2Br?
Does this have alpha protons?
No,
No alpha protons.
so it stays the same.
Why?
Because it's tertiary.
You're asking me why does it have alpha protons or why that one doesn't have alpha? I don't understand why. This carbon here is alpha. Yes or no? Here is the carbonyl and this is alpha. The alpha carbon does not have alpha protons on it. What it has is a CH3 and CH3, so no protons. So this is an alpha carbon with hydrogens on it, which are called alpha hydrogens, yes? Yes or no?
Yes.
And if we do it here, what is it going to be? CH2Cl.
You can put it on each side, right?
You put it on the other side?
Yeah, you can
This
put
one
it.
get it.
But will it do
Guys,
both?
please, it's the same thing on both
That's
sides.
It's the same thing.
Right, but will it do both?
What do you mean, both?
Will it put a halogen on both sides?
Is it gonna put a hydrogen on both sides at the same time?
No.
No. Once, and remember what I told you, yes? I am showing you these reactions. One, you put this chlorine here. Now this is more acidic than before. And it's going to put another chlorine. And then what is it going to do? Put another chlorine, but only on this side. But this side and that side is the same. Yes? You see? This side and that side is the same. And this is Cl, yes?
Yes.
Was that a curveball?
No.
You're like, oh damn, it's not bromine. What am I going to do now?
You're gonna put it on the left-hand side.
And now here, I'm not going to have a choice, yes?
Right.
Yes.
This is going to go
CH2I. Yeah.
here. And how about this one? That's a curveball. If you know about sports, right?
Don't watch baseball, so.
You don't watch baseball? That is,
I'm taking back his bank card.
it's a what?
Okay. I'm taking back his bank card.
You watch baseball?
I'd rather go in person, though. I think they say it's more
You
fun in
almost went
person.
pro.
Yeah?
But I don't have
Play
money for it.
You don't have money. It's free. It's free to go to watch the Marlins play. You know, they give you your whole family a pizza, Coke, and pretzels, and this and that for 40 bucks. If you stay in your house, you spend more money on the air conditioning.
That's true.
All right, so what about this? This H3O plus, right?
Yeah.
I'm confused. That doesn't work? Or it does work? Yes or no? Of course it works. Because I told you already that you can form the enolate with a base or with an
That's
acid.
it. Yeah.
Okay? And this is, the I goes here.
Yeah.
Does this have alpha protons?
No.
No alpha protons. Alpha protons there.
Yeah.
Yes or no?
Yes.
That's a tough one, huh?
Very tough.
No.
You don't have to throw the H's, right?
What happened?
You don't have to throw the other H.
What age?
He said, how would you know? Would you have to draw the other H's to see if there's any protons?
I did not draw any H's here. But if you put an H here, like that, it's fine.
He's asking like, how do you know where?
Anybody with sign, guys? You all sign?
Draw alpha.
Yes.
That's what he was asking. Oh, no, this I remember. I studied this. That's what he was asking. You just tell there could only be like 12 or just one, depending if
Guys, let's say I treat that with a base.
More of a curveball.
Yeah, that's a curveball.
Then it's gonna take off that hydrogen. Right? can remove the high point from right there.
Let's say that the base is not this same base. Let's say that I have this product already. I have this product already. I don't have the influence of this anymore.
Okay.
Okay? That's gone. Now I have this. And I treat this with the base. There's no BR2 in there. It's just base. Base like, it could be like pyridine, lithium, carbonate, some base like that. You want this lithium carbonate back? No. So you guys don't have a confusion with the HCl from before? Or you really don't care? Memorize them both. So here's what's going to happen. What's going to happen is, this a leaving group, yes?
Yes.
I mean, you could pull that proton off. You
Right,
could,
right, that's what I was.
okay? But that one might not give you any product, right? If you pull this one off, what happens?
Then it give you negative.
Pull the proton off. What you have is a negative charge here,
Yeah, negative.
yes?
Uh-huh,
Which can go like this,
right.
and that can leak. So in the presence of a base, what you are going to form,
Double bond, okay.
is a double bond there. This is the alpha position,
Yeah,
and this is what position?
beta.
The beta position. So this is called an alpha beta unsaturated carbonyl.
Nice.
All these names. That don't sound like
So the driving force is here is that this and this is a conjugated. Hello?
Yes, it is.
Looks like I never said before conjugated.
Yeah.
Conjugated, yes
Yes.
or no? Yes, one double bond
Bond.
and
Single
another double
and
bond
a double
separated
bond.
by
Yeah.
what looks like a single bond, yes?
Mhm.
This is conjugated, so the driving force is conjugation,
Okay, that's a driving force. Conjugate.
okay? Maria, why are you so quiet today? Your teeth?
Oh, I didn't even know he was here. Damn.
You don't have diarrhea today?
I'm just writing my resume.
Yeah.
That's all right, man. What time is this class over? 30, yes?
KOD.
Okay, let's do another one. How about that? This is this, yes. Potassium or sodium, yes? Doesn't matter. You like sodium better?
The 2-butyl potassium oxide.
Yes. It's T-butoxide.
Oh.
Yeah, T-butyl. I guess you can call it T-butyl oxide. It's T-butoxide. It's an alkoxide. Why are people trying to come in here?
Because they know about you. You like Socrates. They come from all over.
Professor, to what time is your class?
11:30.
11:30.
You have a class after this?
Yes, we do. Thank you,
At
sir.
what time is your class?
11:30. After you get out, we come in.
At 11:30? No, your class is 11:40, right? Has to be 11:40. Has to be 10-minute break between classes.
It is a special program, that's why. I
As soon as you finish, we're coming in.
Okay.
Oh, that's for,
All right.
that's for summer meeting.
Wrap it up.
We're gonna leave what, 10 minutes early?
Erase that for you.
Are you gonna take that one?
Hey,
That thing is on. But I gotta tell you, this that we have here is also a special program. So, tell me, in our special program,
What's this?
the CL at the alpha?
The CO's gonna go
The
to
CL at the alpha?
It's gonna go to the,
Yeah.
very good.
Could have been on the left too, right? No matter.
Could have been on the left, I just like the right more.
yes. Cause men are.
And then with that
But you-
base,
let's put it on the left.
they messing up the
I like
cheat.
the right.
Yeah, the left thing.
You like it right, so let's keep it,
Left.
interesting.
Varieties of spice of life.
So after this, and we treat this with a base. You never
Then you got
seen this
that
base,
double
yes?
bond. No.
You
Yeah,
never seen it?
Yeah.
No, I mean, you have seen it, but not for this
Not
type
for
of
this.
reaction.
No.
But it's still a base, yes?
Yes.
Same thing.
And what you get is
That double bond.
double bond,
Substituted.
right?
Is there any specialty to this base? Like,
That one?
yeah.
Not this one?
No.
Where is the double
No.
bond?
Right.
See, we get it
Right
right, cause
there.
we're adding.
Yeah, right there, because it's driven by conjugation.
We put it in the other place.
Yeah, it's conjugated.
Oh,
That side
no.
and this side is the same, right? But
Yeah.
yeah, I put it on that
That
side, so
side.
let's put it on this side.
See what happens, we're extra special.
Yes.
Also, it doesn't matter. Even if you put it on the left and then you let everyone put it on the right, it's the same difference.
It matters if you put it here, it's totally crazy.
Oh, of course, yeah. No,
But if you put it here, it's the same thing as putting it there. Just like if you put this chlorine there, it's the same thing as putting it here.
Recording the date.
You want to call it a date? Who wants to do the Hell Volhar-Selinsky?
Yeah, that sounds cool.
No, I had that measurement wrong.
Hell,
That sounds
Hell,
sweet.
you know what hell is?
Hail Mary.
Hell Volhar-Selinsky.
It's called ski.
Everybody picking up. Eh?
You just scared them.
Hell
Too
Volensky.
special.
How many questions will you
Hell
have?
On the
Skelinsky.
next test, an immense amount.
There will be many questions.
I don't know, 30, 40, 50.
That's it? We're not-